this video, we're going to talk about message brokers. By the end of the video, you should have a grasp of the basic principles behind a message broker. Broadly, what they do, some possible use cases for them, and be able to identify some examples of message brokers. This is an introduction video and we won't be going into the implementation details of any specific broker. So what is a message broker? Before we get into exactly what a message broker is, let's imagine a completely different scenario. Here we have Rachel and Donald. Rachel wants to tell Donald something. Let's say it's a list of things that he needs to do that day. I think we all agree that the fastest way for that information to get from Rachel to Donald is for her to tell him directly. One person telling another person something is an excellent way of communicating. It's how all the fairy tales and childhood stories that you're familiar with have been passed down since before the written word. This method of communication has served humanity well. It works especially well if the thing that you're trying to communicate is simple and time sensitive. For example, if she was telling Donald that there was a tiger behind him, direct communication is definitely the way to go. However, in our situation, the information is not only not time sensitive, at least not to the second, but it might be quite detailed or complex. She might, for example, be telling him to go at the shops and buy some onions, or perhaps she's telling him that there's a delivery due and he needs to pick it up, or the ingredients to make the dinner that night. Now, let's imagine that Donald is distracted while she's telling him what time to put the oven on. He might miss that information. Poor Donald. He'll end up with raw chicken. One alternative here is that Rachel could write down the information. She can then pass that to Donald. This solves the problem because Donald can now look at the information anytime he chooses. Now let's imagine that it's a long list. In fact, let's imagine that the list is so long that Donald simply can't complete the tasks in a single day. One option here is to get some people to help out. There we are. We now have 3 people to help Donald. But we only have one list. Donald has an idea. He cuts the list up into several pieces. The helpers then come to him when they're ready for a task, and he hands them out another piece of the list. As Rachel leaves for work, she comments that Donald is making a really good message broker. Donald spends the rest of the day passing out slips of paper. He hands out slips to each as he is asked for another task. Let's come back to what a message broker is then. In fact, Donald was our message broker. However, in software terms, our message broker must technically fulfill 3 criteria. Donald worked as the message broker. He was a discrete entity. In software terms, that means that the message broker must run in its own process. Rachel never spoke to any of Donald's friends. Since he was the message broker, only he could speak to the publisher, that's Rachel, and to the consumers, his friends. There are essentially 2 methods of communicating using a message broker. The one that Donald and his friends used was a queue. The other is a topic. We'll cover this in more detail soon. Okay, I think the Donald and Rachel analogy has gone about as far as we can take it. Let's talk about some concrete features of a typical message broker. Let's talk about queues. In a queue, messages are sent to the broker and held there. Usually this maintains the order in which they were received. Consumers read the messages from the queue. The example shown here is known as the competing consumer pattern because multiple consumers are processing messages. Queues also work fine with only a single consumer. In fact, a queue can exist with 0 consumers. Topics, or the publish and subscribe pattern, also known as pub/sub, operate as though each consumer has its own private queue. Messages are sent to the broker in the same manner. Messages are forwarded to any subscriptions that are currently held. This means that, unlike a queue, there cannot be 0 subscribers, or rather, if there are 0 subscribers, the messages are still delivered to all of the subscribers. In this case, none. We've spoken about what a message broker is, but why would you use one? One possibility is that when you get a spike in traffic, your service isn't adversely affected. Another reason is to facilitate communication across a distributed system. This covers things like microservices, but also architectures that you may not think of as a typical distributed system. For example, if you're using an AWS Lambda or an Azure Function just to send emails, you might use a message broker to provide the queue of emails. Another use case is that you have a high workload and you want to distribute the work between multiple clients. You could use the competing consumer pattern that we saw earlier. This isn't an exhaustive list. There are dozens of possible reasons. Anywhere that you need to store a list of data that is written to one place and read from another. In this video, I've tried to keep all of the language very generic, so that it's applicable across different brokers. However, these are some of the possible options. This is far from an exhaustive list, although it does feature some of the better known options. Each one has pluses and minuses. Broadly, the payment model for the commercial offerings are in the hosting of the service itself. The open source and free options tend to have additional support or consultancy that you can choose to pay for. Some provide all the features that you would expect from a message broker, and some provide very limited feature set. Thanks for watching.